Welcome back. In this video we're going to continue looking at malloc. So last time we looked at creating a single short. This time I want to create an array of shorts, and this is usually the case for our malloc. Is we're going to create larger data structures. For us, most of them are going to be arrays, but later on we're going to have structs as well, and we'll also have two-dimensional arrays, which will be part of the last assignment. So we're going to have a look at malloc again, and in terms of arrays. So this time I'm going to create an array of 10 shorts, and how I'm going to do this is I'm going to create my pointer. I'll call it pointer. This here this name should be the name of the array, but we don't have a domain at the moment, so I've just called it pointer. Once again, short star, as before, malloc, size of, short, and then I'm going to multiply it by 10. Okay. So here, what I've got is I've got short, which is 2, times 10, which is 20. Okay, so I've got 20 bytes, which makes up 10 shorts. Okay. Now this is important, and you can do more complex values here. You could do for example, some arithmetic. You have to be careful though that you do get the right amount of shorts or bytes or whatever you need in the end. So what does this say? So we'll draw a box and pointer. We'll draw a box and pointer diagram once again. We've got our heap, okay, and we've got our pointer. Probably make that heap a little bit bigger because we'll need a bit more room. And you'll see that this looks like an array, but not quite. Okay, what we're familiar with. So I'm going to draw this. I probably shouldn't have done 10. Maybe I'll change it to 5, just so that I don't have to draw as much. So we'll do 5 here, which gives 10 bytes and 5 shorts. Okay, just to make it a little bit easier for drawing it. So 1, 2, 3, 4, 5. And this is a little bit different than our box and pointer diagrams for our arrays, but kind of looks similar. But you'll notice that we've got this unnamed memory. We don't have the little pointer to the start either. The values at this stage are uninitialized, so we don't know what's in there. There could be anything in there. And we've got this pointer pointing to the start of it. Okay, so remember, malloc returns a pointer to the start of this memory address. Now, if I want to access one of these, I can. So I could do something like, let's say, dereference ptr plus 2. Now remember, when we add to a pointer, we're really saying pointer plus 2 times the size of the type that it's pointing to. Okay, and I'm going to put 4 in there. Okay, so we start here, plus 1, plus 2, and we end up here. Now we also remember that a shorthand way of writing this is our square brackets. So I could say pointer, let's say 1 has a 2 in it. Okay, and this will just put a 2 in here. Okay, so we can use array notation because we've got a pointer here, and the square brackets is just a shorthand way of writing this here. Now, one thing that you need to be really careful about. Sometimes you might want to iterate over your array. Never do this. So pointer plus plus. Now, why we don't want to do that is because that changes where this pointer points. Okay, so now it points here. Now there's nothing in memory telling me where the start of this array is. And so if I change the start, now I've lost the start of my array. Okay, and that can be really, really bad because I need to know always where the start of the array is. So a better option is that if you need to iterate with another pointer, or go over or point at something else in the array, create a copy first. So short star ptr copy, and that's going to become pointer. Okay, so it's just copying that memory address in. So we'll call this ptr copy, and it's short star. Okay, and it's going to point at the first one as well. Okay, because all it's doing is copying that memory address. And then with the copy, I could do something like pointer copy plus plus. Okay, now your increment operator also increments by the size of what it's pointing to. I don't know if I mentioned that earlier, but it does. Okay, so here I go to here, and I still keep that original pointer. You don't want to lose your memory because it's going to make things difficult. Now, with all of this, okay, we really want dynamic memory. So for our problem, usually this 5 is not going to be a literal. Okay, we want it to be dynamically allocated, so change. So what we can do instead is do something like this. Printf enter size of array. Okay, we just asked the user for the size of the array. We'll make an int called array size. We'll do a scanf. We'll get that value off the user. Okay. And then we can put that in here. Okay. And this allows for a dynamic array. Okay, because now every time the program runs, this can change different sizes depending on what the user enters. Okay, so this is going to be very powerful, and it allows us to create dynamic arrays, and once we've created it, we can use it like a normal array. Now when you're finished using it, you can just free ptr or whatever you've named your array, and that will free all of it. Okay, not just the first part, but it will free all of it. Just make sure that you are pointing to the start and you haven't moved it around, okay, because it won't work properly. Okay, the same thing goes, you can still use your if and check if it was null like we showed in the previous video. Okay, and that will still work as well. All right, and we can exit if the memory isn't allocated. Alright, so that's it for this video. We'll have a look at one more thing with arrays in the next video, and then a little bit later we'll look at two-dimensional allocation of memory, because that gets a little bit more difficult. Alright, that's it. Thank you.